Okay, today we're going to be diving into domains, ranges, and functions. The whole purpose today is to kind of define what a domain is, what a range is, and what makes a function a function. Beginning with domains, the domain is going to be the x value of an ordered pair, or that first value in an ordered pair. So if you look here, we have the ordered pair 10, negative 2. Uh, because 10 is our x value, or the first one, we would consider that to be the domain. So the domain of this ordered pair is 10. The range is going to be kind of the opposite. The range is the y values, or the second um, value in an ordered pair. Here's the second one because it goes x, y, and so the y value, or given this ordered pair 10, negative 2, the range would be negative 2. Looking at a few examples, we're going to give the domain and ranges. I'm going to go ahead and mark a few of these back for us so we can focus on just one at a time. But here they gave us a list of ordered pairs, and we need to list the domains and ranges of each. The proper notation for listing the domain is when you give a capital D with the dots and then the brace here. So now we need to pull out all of our x values. The x values are always the first one in the ordered pair, so we get 0, 2, negative 4, and 5. And we're going to end it with our last brace. And so notice I separated them with commas. Our ranges are going to be the second one. We're going to consider that our y value. And we're going to note it just the same. And our range is going to be 1, negative 3, 4, and 5. It's important to realize that if there would ever be a repeat in either the domains or the ranges, for example, if we were to change this domain to a 0, if it would have changed to a 0, then we would have technically 2 zeros in here instead of this 2. We only need to note it once. So in instances where you have a repeat in either the domains or the ranges, you only need to represent it once within your notation. When given a t-chart, it's the same thing. Our domains, remember, they're always going to be the x values, and our ranges are going to be our y values. And so when we want to list our domains in this situation, it would be 1, 3, 5, and 7. Because all of these are our x values. If it helps you to think of them as an ordered pair, you can. And the x value of the ordered pair of each one of these would be this left column. The ranges are going to be 0, 1, 5. And notice there is another 5. So 0, 1, 5. And because there's another 5 and there's that repeat, we do not need to represent it twice. We just simply need to have each one at least represented once. And now looking at it in graph notation, given a graph, the easiest way, I think, would be to write the ordered pairs for each point. This one would be negative 2, 1. This one we're going to go over positive 2, up 3. And this one over positive 2, up 5. So now, I'm going to move this over. If we list these out and have our negative 2, 1, our 2, 5, and 2, 3, it's pretty much like having our XY t-chart. So now we can clearly see our domains and ranges. And so I can write out that the domain is negative 2, comma, 2, but notice there's a repeat, so we only need to list it once. Our range is going to be 1, 5, 3. Okay, let's try another example. This time we're going to be not only looking at our domains and ranges, but we're also going to try to figure out what makes a function a function. The rule of what makes a function is basically anything is a function if there are no repeats in the domains. And so what I recommend doing is building a t-chart and putting all of my x values on the left side. And we're going to have 0, 3, -2, 1. And then all my y's on the right side. 1, 4, 5, and 0. And then looking for repeats in the domains. Remember, domains are the x's. So look right here. If there are no repeats, meaning any numbers here that are written at least or more than once, if there are no repeats, then we're going to call that a function. So yes, these are an example of a function. Over here we have a different way of noting it. It's called a mapping diagram. But we can still use this to make a t-chart. In a mapping diagram, the first box is always your x, and the second box is always your y's. And it uses arrows to note what it's paired with. And so the ordered pair, the first ordered pair here would be 1, 0. The second ordered pair would be 1, -2. Because if you notice, 1 is paired with 0 and then also paired with -2. The next one would be 3, -2. Again, we're making a t-chart here. Then we have 5 paired with 5. And then 7's paired with 5. And so when we look at this, to determine whether or not it's a function, we need to look at our domains and see if there's any repeats. If you notice, 1 is repeated. We've got it paired with 0 and also paired with -2. So that would mean that this is not a function. Okay. Another way to test on whether or not it's a function is by using what we call the vertical line test. The vertical line test says if you draw a vertical line and you move this vertical line over the function, so if you notice the function is this arrow that is drawn here, this line, if we move this vertical line over that, it can only come in contact with that line once. So maybe it would help if I kind of trace this line. And we're going to call it the red line. Put my arrows on the ends. Now, our vertical line that we draw can only come in contact once at any point with the red line. So notice there's no spot that we can move this vertical line anywhere on here to where it comes in contact more than once. Because it comes in contact only once, we call that a function. It passes our vertical line test. If we take our vertical line over to this function, and the function in this one is a circle, you can notice that here it only comes in contact once, but as we move across, it comes in contact more than once, twice to be exact. Because it comes in contact over through this area here twice, we know that this is not a function. Okay, so to recap, there are two different ways to figure out whether or not a function is a function. One, if there's any repeats in the domains. And 2, the vertical line test. We also learned that domains are always going to be our x values and ranges are always going to be our y values. I hope that helps.